All right, so we are going to talk about the features of waves. If you remember, we talked that there was two types of waves last time. So we had your transverse waves that kind of just goes up and down like you'd picture any type of wave going in the water. And then we have the compressional waves, which are more like slinky type waves. So please remember that we have those two types because we're going to now talk about the features of those actual waves. So first we'll look at transverse waves. And transverse waves have crests. That's the highest point of the curve. And they have troughs, which are the lowest points. So this is a crest, a crest, and a trough. Compressional waves, conversely, have two areas. They have dense regions where the waves come really close together, right here. Okay, and that's called a compression. And then they have less dense regions where the coils are very far apart, and those are called refractions. Okay, refractions. So understand that there are those two regions. So here we have crests at the top, troughs at the bottom. Here we have compressions where they're very close together, and refractions where they're very far apart. So all waves have wavelengths, frequencies, and amplitudes. So a wavelength is the distance between one point of the wave and a similar point nearest to it. So maybe measuring from crest to crest, how far apart are the crests from each other? Or trough to trough, how far apart are the troughs from each other? Or compression to compression, or refraction to refraction. Understand that wavelength of a wave decreases as the frequency increases. Well, let's go ahead and look at the frequency. The frequency is the number of wavelengths that pass a fixed point each second. So something with a high frequency has a lot of waves that pass it in 1 second, and something with a low frequency has less waves. And the unit that that's measured in is called hertz, or Hz. Finally, there's the amplitude. This is a measure of the energy in the wave. The more energy a wave carries, the larger the amplitude. So more energy, more amplitude. So distance from the crest to the trough to a normal position in a transverse wave is how we calculate the amplitude in transverse waves. Or the density of the compression is how we calculate the amplitude of a compressional wave. So in transverse waves, remember the wavelength is from a similar point to a similar point. So if this is the crest, this is the crest. From crest to crest is the wavelength. Okay, or from trough to trough, but we don't have a trough to trough. Okay, the frequency, high frequency, look how fast they go up and down and how many we get in this specific area. Here, we get a lot less waves in that same specific area. So this is a high frequency because we get a high number of waves in that same amount of area. And this is low frequency because we get a low amount of waves in that specific area. The amplitude, again, is from the resting position, or the basic line, all the way to the top of the crest or the top of the trough. Or bottom of the trough, I should say. So this is the amplitude in transverse waves. So understand the wavelength, frequency, and amplitude when it comes to transverse waves. In compressional waves, the wavelength is a distance from the similar areas on the compressional waves. So where the density is this to where the density is that again is going to be a single wavelength. Okay, a single wavelength. When looking at frequency, it's how often they go into those little dense areas. So notice here, we have the same distance. This is one wavelength here, but in that same wavelength here, we have 3 compressions. So this is higher frequency than this. This is a low frequency because look how far apart they are. We get more compressions here than we do here. Amplitude is the line density, so how many lines are actually squished together. So when there's a lot of lines that are squished together into a small area or a higher line density, you get a greater amplitude. When there's less lines, it's less of an amplitude. So remember, amplitude is energy. So when the amplitude is high, when we have a lot of lines pushed together, that is a high energy wave. And when we have less lines pushed together, that will be a lower energy wave. So to calculate wave speed, so waves move, we talked about wavelength, we talked about frequency, and they all have to deal with the wave speed, how fast the wave is actually moving. So to calculate wave speed, it's calculated in meters per second. That's how fast the wave is moving. and you need the frequency in hertz and the wavelength in meters in order to calculate this. And to calculate it, it's just the wave speed is going to equal the frequency times the wavelength. So understand that, because you'll have to calculate some wave speed. So please let me know if you have any questions. That is all for this video, and thank you for watching.